Now let's talk about the fundamentals of what exactly this RAM is, or what this type of memory is, right? Because I said there were different types of memory. So how does this memory, in this particular type of memory work? Well, the first thing I want you to know about RAM is that it is what's known as temporary memory, or sometimes referred to as volatile memory. Okay, so we have our volatile memory, and then we have our permanent memory. Permanent would be something more like the memory of your hard drive, right? We actually write data to the hard drive, and it's permanently there, or at least mostly permanent. And I say permanent in the sense that it can be deleted, or a hard drive could be damaged, things like that. But as far as the regular functionality of it, it's permanent on a hard drive, whereas when it's in RAM, it's volatile, which means it can only maintain as long as there's power, right? And so here I'm using the example of something called a capacitor, right? So if you know what a capacitor is, these are tiny little components of a system of internal conductors that temporarily store an electrical charge, right? That's what a capacitor is. And that charge, or the data, which is in the form of electrical charge, can be retrieved later when it's needed. And it's interesting because if you've ever actually touched a capacitor, right, you have this electrical energy stored in the capacitor, and if you ever touched it and got a shock, and I'll tell you, it can be quite the shock. Some of these tiny little capacitors can really hold a lot of energy. Well, then you've actually experienced the process of data flow, just the way it does from RAM over to the processor. It stores that data to be released. And when you touched it with your finger, it was released into you. That's why you got a shock. But the one thing you want to keep in mind is that with these capacitors, they eventually lose the stored electrical energy. Okay, that electrical charge that it has, it will lose that eventually. It cannot store it permanently. And one of the analogies that I've heard is it's kind of like a leaky container. Okay, so if you picture, maybe you have a bucket and it's got just a small, tiny little hole in it, tiny leak in it. That's really what a capacitor is like. It actually does have a tiny little leak. So it's not permanent storage, it's only temporary storage. Now, if one capacitor can store an electrical charge, which these charges are like zeros and ones, right? We talked about, I briefly mentioned in the processors lesson, I mentioned about bits of information, and a bit is a 0 or a 1. Well, this is all done with electricity, because electricity can either be in an on or off state, right? And so it's kind of like a 0 or a 1. So if one capacitor can store, an electrical charge, then you can imagine what you could do with more than one, like a collection of them. Well, that's essentially what RAM does. It stores a series of these electrical charges in a group of capacitors. Okay, so it has all these zeros and ones to truly make up the data that we're trying to store. Now on the screen, I have a picture of just, a typical memory chip. Okay, and I don't want you to worry about the chips yet, okay, because they come in these different form factors. That's a term that we heard back in the motherboard lesson. But they come in all sorts of different shapes and sizes. And really, they're all the same shape. Just different sizes and capacities, really, I should say. And we'll talk about that a little bit later. So I don't want you to worry about that. I don't want you to worry so much about what it looks like. I just wanted you to kind of see this is what a memory chip looks like. But I want to tell you, it didn't always look like this. Back in the really, really, really old days, we actually had RAM, we actually had this memory sometimes soldered straight onto the motherboard. Okay, but that obviously posed certain limitations, right? If it was hardwired in, you couldn't expand upon it. And I can also tell you that memory used to be measured in bytes, and then it was in kilobytes. Like, I actually remember owning a computer. It was the first computer I owned, and it actually had 1 kilobyte chips. These little cards that we put in. It had these kilobyte cards. So, yeah, we used to be in kilobytes, and obviously we moved to megabytes, and now we're talking in gigabytes. But before we get into all of that, I just want you to understand that each RAM module Okay, so each of these little cars here, it has multiple memory chips, and you can kind of see that illustrated. Like you can see these chips. Some of it you can see right on the top there. Each chip is organized into columns and rows. Each chip also has a defined column width, right? So like 8 bits, 16 bits, right? We talked about that before. It's like, right, dealing with the width of the bus, right? We talked about the bus speed and the bus width. Each chip also has a specific number of rows. So you take these rows and columns and you put that together into one of these cells, and that's how it all works. Now, that might not make a whole lot of sense when you look at it this way. So if we look at it this way, when we look at each of these chips and say, hey, we have a certain number of columns and a certain number of rows. Well, the columns and rows is what determines the overall capacity of the RAM chip. Okay, so you picture that we have this grid here, and you can put data into each one of these little cells, right? And the data is these ones or zeros, right? Meaning either it's charged or it's not charged. So first we have this grid determining the capacity of the chip, and then the number of chips we put on the stick itself, on the module, determines the capacity of the overall piece of RAM that you're putting into your computer. Now, as far as a little bit more about how RAM actually works, we have something called DRAM, or dynamic RAM. Well, what happens is the information that is stored in each one of these cells has to go through a process called a memory refresh. Right? So there's these refresh cycles where it goes through and it gets a new charge of information, right? It refreshes the data that's supposed to be in all the cells because it can't stay there very long. Now, RAM, I will also tell you, is, again, it's considered to be the main system memory. That's why when you say how much memory you have in your computer, lots of times we're talking about RAM. It can either be installed on the motherboard, as I mentioned in the old systems, or it can be on chips, which you then insert into a motherboard. Okay, so either way, it needs to be on the motherboard in order to be able to communicate with the processor. The cells are made up of individual capacitors. These capacitors hold temporary electrical charges. Since it's temporary, that means that the charge is going to dissipate. So we have to have this little refresh cycle so that the data is not lost, right? We refresh it, we recharge the energy. And we can do that as long as the computer's on, right? As long as there's power from a power supply. I know we haven't talked about power supplies yet, but that's another lesson. But as long as there's power coming in to the motherboard and the memory's on the motherboard, this stuff can be refreshed. Now, DRAM is not really something that we see too much anymore because the original DRAM operated in an asynchronous manner. Whereas in today's systems, we now have something called SDRAM. And the S stands for synchronous. So we have our synchronous dynamic RAM, right? The DRAM means it's dynamic, right? So we're going through this constant refresh. Synchronous dynamic RAM, or SDRAM, means that it's tied to the system clock just like the CPU. Okay, so basically we have everything working in sync within our system. Okay, so as we're going through cycles of the CPU, we're going through cycles with refreshing memory. And that's where SDRAM comes from.